Hello and welcome to the section on similar figures. As you know, similar figures have the same shape but may have different sizes. And if two geometric figures are similar, then corresponding sides are in proportion. Let's go to the board now and work our first problem. We have two similar triangles. Triangle ABC is similar to triangle EFG. And in these two similar triangles, side AC corresponds to side EG, side AB corresponds to side EF, and side CB corresponds to side GF. In other words, the longest side in one corresponds to the longest side in the other, and the shortest side in one corresponds to the shortest side in the other. Now, we want to find the length of side AB, so I'm going to call that X. I'm going to call that length X, and I'm going to set up my proportion this way. I'm going to say X is to 6 as 6 is to 4. So X is to 6 as 6 is to 4. So I'm using that property I have for similar figures that says if two figures are similar, then corresponding sides are in proportion, which means that this side is to this side as this side is to this side. Okay, so now I have my proportion. What I'm going to do is use my means extreme property to solve this proportion. So I'm going to say X times 4 is 4X, and then 6 times 6 is 36. Okay, I'm going to move that camera down a little bit. There we go. Now we have a little bit more room to work. And let's see, 4 times X is 36. If I divide both sides of this by 4 or multiply both sides by 1/4, I end up with X is equal to 9. So in this problem right here with these two similar triangles, if the two triangles are similar, then corresponding sides are in proportion. That allows us to set up this proportion right here. We use the means extreme property to multiply X times 4. We get 4X. 6 times 6 is 36. Then we divide both sides by 4 to end up with X is equal to 9. So if these two triangles are similar, then it must be true that X is equal to 9. Let's take a look at our next problem. In this problem, I have two similar rectangles, and I've drawn this width right here as 12, this length is 16, this width is 9, and this length is X. And since these two rectangles are similar, the width in one is to the width in the other as the length in one is to the length in the other. So again, I'm going to just use the fact that corresponding sides of similar figures are proportional and write my proportion this way. X is to 16, so X over 16 is equal to 9 over 12. So what I'm saying is this side is to this side as this side is to this side, or X is to 16 as 9 is to 12. So that gives me a little proportion here to solve, and so I'm going to use my means extreme property. X times 12 is 12X, and then 16 times 9, I believe, is 144. So I have 12X equal 144. I'll divide both sides by 12, and I'll end up with X is equal to 12. So if these two rectangles right here are similar, then it must be true that X is equal to 12, because this side is to this side as this side is to this side. I set up my proportion. I use my means extreme property to multiply X times 12 and 16 times 9. That gives me 12X equal 144, and then I solve that to end up with X equal 12. So again, if two figures are similar, then corresponding sides must be in proportion. Let's look at one last problem. In this problem, we have a tree casts a shadow 38 feet long when a 6-foot man casts a shadow 4 feet long. Now, what you have to assume about a problem like this is that the rays from the sun are what cause these shadows to be whatever length they are, and that the rays from the sun come down parallel to each other so that we end up with two similar triangles right here. So if that's the case, then we can find the height of this tree right here using our property of similar figures that says corresponding sides are in proportion. So that means that the height of the tree is to the height of the man as the length of the shadow of the tree is to the length of the shadow of the man. Or X is to 6 as 38 is to 4. Now, I can use my means extreme property to solve this by saying that X times 4, which is 4X, must be equal to 6 times 38. Now I'll work that out on a calculator. That means that 4x must be equal to, what do I get here, 228. 228. I divide both sides of this equation then by 4 to end up with, let's see, 228 divided by 4 on the calculator is 57. 57, and I'm going to put my units in here, feet. X is equal to 57 feet. So if a tree casts a shadow 38 feet long at the same time a 6-foot man casts a shadow 4 feet long, then the height of the tree must be equal to 57 feet. And we found this by using our property of similar figures that says corresponding sides are in proportion.